All right, this is 5.1e. We're going to talk more about functions. We're just going to continue where we left off. All right, so this is kind of a review. Paradise Orchard has a banner showing in their window. Sally's trying to determine how much she will spend depending on how many bushels of apples she purchases. So it says that one bushel is $15, $15. So let's write an equation first of all. So y is the total amount she will spend, and x is the number of bushels of apples. So your equation should be y equals 15x. So x is the number of bushels, y is the total spent. So let's fill in that table. We have done this so many times before. If she doesn't buy any, she doesn't spend any. If she buys one, she spends $15. If she buys two, she's at $30. Three, we're looking at $45. Four, she is at $60. So let's go ahead and fill in that table. I'm going to put x is the number of bushels. So if you can see, I labeled the x-axis number of bushels, the y-axis money. I went up by 15s on the y-axis and 1 on the x. I wanted to talk about something else before we plot. That anything that you plot on your x-axis is considered the independent variable. That means it stands on its own. Anything that you plot on the y-axis is called dependent because it depends on what the independent variable is doing for its value. So y is dependent value, your outputs. X is your independent value, your inputs. So let's go ahead and plot. I knew it wouldn't let me. Let's go ahead and plot. So we have 0, 0 here. 130, 115, 230, 345, 460. Don't connect the dots. Do not connect the dots there. So remember, x is independent, y is dependent. That's going to be coming back around. All right, let's turn the page. All right, Miguel is taking a road trip and he's driving at a constant speed of 65 miles per hour. He's trying to determine how many miles he can drive based on how many hours he drives. So let's figure out what our independent variable is. What doesn't change because of the other one? Well, you can't change time. So the hours he is driving is his independent variable. And we can put that for x here, hours driving. Because our independent variable is always our x value, our input. So then the dependent is miles. How far can he go? Or the distance traveled. All right, so let's complete the graph. If he's not driving any hours, he's not going anywhere, right? If he drives 1, he's 65 miles away. 2, we're looking at 130 miles. If he drives 3 hours, we're at 195 miles away. And if he drives 4, he's 260. All right, if we were to write an equation for this, it would be y equals 65x. X is the number of hours. So you're multiplying 65 times the number of hours to get y, your total distance traveled. So let's graph this. Let's put hours here, which is time I told you is usually on the x. And then we're going to put miles up here. I'm going to go by ones here, skipping every other one. And then as far as miles, I'm going to go up by 20. 30s. 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360, $3.90, $4.20. Yep, that's right. Okay, so now let's graph this. 0, 0, 1, we got to go in right between. 2, he's 130. 3, 195, right here. 4, 260. Got to kind of eyeball that. Okay, so let's look at E. This is tricky. So is the distance traveled a function of hours driving? Well, look at this. We could use the vertical line test. We could use hours. So when we write this, and this is what we talked about in the birthday problem, so the y is a function of the x. So it would be distance traveled is a function of hours driving. So y is a function of x. Okay? All right. Number 3. The drama club is selling tickets to the fall ball. They use $2 from each ticket sale for food and decorations. So let's identify the independent variable, the variable that stands on its own, that doesn't depend on the other one, that's not changed by the other one. That would be the number of tickets sold here. And then the amount they spend on decorations depends on how many tickets they sell. If they only sell one ticket, they only get $2 to spend. So the amount spent on decorations is your dependent variable. Let's label our X and Y then. Remember, independent is our X, so this is number of tickets sold. And this is the money spent on decorations. Okay, so we don't sell any tickets. We got nothing to spend on decorations. We wouldn't need to anyways, because no one would be there. If we sell one, we have $2. 2 tickets, we get $4 on decorations. 3, we get 6, 4, $8 for decorations. So my equation is y equals 2x. For every ticket we sell, we get a total of $2. All right, let's label our graph. So this is the number of tickets over here. And this is the dollars for decorations. Okay. I'm hoping more people show up to a dance than that, but we're still going to go by ones. Here I'm going to go by ones too. So I'm going to do 0, 0, 1, 2, 2, 4, 3, 6, 4, 8. In this situation, remember, y is a function of x. And it is, there's no repeat x values. You can make a linear equation from it, passes the vertical line test, all that fun stuff. So the money spent on decorations is a function of the number of tickets sold. So there we go. All right, let's move on. The cost of an average movie ticket has increased steadily over time, which is the truth. So identify the independent and dependent variables. Well, the independent is time. And the price of a ticket is your dependent variable. Oh. All right, so a possible graph, this is time, we could say years, and this is price of a ticket. Obviously, it's going to go up, so we can just draw our line like that. There's no dollar signs on there, but this is just a general trend. All right, let's move on. So the next one says Susan is reading her history textbook for an upcoming test. She can read 5 pages in 10 minutes. Susan is interested in determining how many pages she can read based on how long she reads for. So we have 2 variables here. We have time and number of pages. So what's independent? And I told you that most of the time is independent, and the number of pages she reads depends on that time. So we are just going to write an equation for that. So 5 pages in 10 minutes. Remember, the time is your x. Let's look at the table. The time, let's do hours. Oh no, this is minutes. They said minutes, so let's change that to minutes. And this is pages. So she can do 10 minutes, 5 pages. So remember, your rate is y over x. So this becomes 1/2. So your equation is y equals 1/2 x. So if in 20 minutes she reads 10 pages, 30 she reads 15, 40, 20, 50, hold on, back up the truck. So every 10 minutes she reads 5 pages. I was right. So at 30 she'll be at 15, 40 she'll be at 20, 50 she'll be at 25. So every 10 minutes she's reading 5 pages. All right, let's go on to 6. We're not going to spend too much time with the graph and table here. I'd like just to identify the independent and dependent variable. Chris is also reading his history textbook for an upcoming test, and he also reads 5 pages in 10 minutes. However, he is interested in determining how long it will take him to read based on how many pages he has to read. So we're going to flip that upside down. That means he wants to make the independent variable the number of pages. And then the dependent variable is the time. So he wants to know if he has a certain amount of pages to read, how long is it going to take him? So this makes your equation flipped upside down, and that's your equation. So let's identify the independent and the dependent variables. In warm climates, the average amount of electricity used rises as the daily average temperature increases and falls as the daily average temperature decreases. Your dependent variable is the amount of electricity. Which makes your independent variable the temperature. So the amount of electricity you use depends on the temperature it is outside. Temperature.